Thank you, Dr. Stoker. Thank you all for making the time to attend this talk. My German is very poor, but I think I'll try Guten Tag as a way to start off. So I'm kind of just going to jump into the talk. So the idea here is that we have sort of established frameworks of governance in AI, and what I'm trying to propose in this talk is a new way of governing AI. That's the underlying um, motivation behind the talk. So just to kind of quickly introduce some things. A couple of years ago, we had ChatGPT come out, and while AI has been around for a long time and it's been used for a long time, because of ChatGPT, there was certainly renewed interest in regulating AI to try and figure out how to regulate AI in a way that's not too innovation stifling. So, US has its own, US had the AI executive order, Europe has the EU AI Act, China has a bunch of different regulations around AI. And then that's kind of on the government side, on the kind of civil society and academia side, there's a lot of work being done by academia. Timnit Gebru, Deborah Raji have made a lot of proposals in terms of how to govern or regulate AI. Um, but it's kind of it's kind of a tricky situation because you do want to make sure that the harms of AI are being somehow addressed, but at the same time you don't want to limit the benefits that you can get out of AI. So you kind of anytime you want to regulate something, the underlying that is there are basically two economic approaches. And from what I understand, a lot of the people on the call are economists, so this is probably going to be fairly well trodden ground for you all. But there are basically two kinds of goods, right? So you have private goods, which are both rivalrous and excludable. Rivalrous is easy to understand. It's basically the idea being that if, let's say, you have some ice cream, if I consume that ice cream, that ice cream is no longer available to you, right? So it's rivalrous. It's also excludable. So if I have a tub of ice cream and I refuse to give it to you, then I can exclude you from consuming that ice cream. So private goods are both rivalrous and excludable. So I stick with my favorite example of an ice cream. On the other hand, you have public goods. So they are both, they're the opposite of private goods. They're non-rivalrous and they're non-excludable. So one kind of big example of that is national security. So if I'm enjoying the benefits of national security, you don't have any less national security to enjoy for yourself, right? So it's not rivalrous. And just because I'm enjoying national security, I cannot, prevent you from enjoying national security or the benefits of national security. So it's also non-excludable. So based on these two kind of fundamental approaches of regulating, not just AI, but really anything, you get regulatory policy. So for example, public goods approach to immigration, for decades and decades and decades, the United States had a bunch of laws that are together called the Asian Exclusion Acts, which would basically say that, it's a public harm to have Asians in the United States. So they barred any Asians from immigrating to the United States. On the flip side, similarly, at a different point in history, the US government decided that, oh, it's actually good to have certain kinds of immigrants, especially high skilled immigrants in the country. So they turned around and created the O1 visa program, which explicitly targeted high skilled immigrants, which ironically generally was used by Asians. So you can create a program that would prohibit immigration based on public goods, but you can also create a program that would encourage immigration, again, based on public goods. You can also have immigration policy based on private goods. So, for example, in the United States, I do apologize for the US-centric examples. The Immigration and Customs Enforcement Agency has a tip forum where they allow people to report, any kind of grievance they have around, with the immigrants that they encounter. So the idea there is, you're sort of saying that, immigration enforcement is now privately led, wherein private individuals are going to work with ICE to enforce immigration. Similarly, you can also encourage a private goods approach to immigration. or you can use a goods-based approach to immigration to encourage immigrants. So again, in the United States, we have something called the U.S. Welcome Corps program, where any 5 U.S. citizens can get together and sponsor refugees and other immigrants from other countries. So this is kind of a general example, right? Like, how does this apply in the context of AI? So if you look at the EU AI Act, from my perspective, it's sort of a public goods approach to regulating or governing AI. So in the EU AI Act, it prohibits use cases that have unacceptable risks. So again, similar to the immigration example that we saw before, where the government might decide that certain things are just harmful to the public at large, and so they have to be prohibited. So in the immigration example, agents were harmful to the public at large, so they were prohibited. In this case, you have certain AI use cases that are harmful to the public at large, so they are prohibited. And then a different for high risk use cases, you might not prohibit them entirely, but you might then require some ex ante guardrails. I believe like one of the guardrails is you need to have human oversight for any of the high risk use cases in AI. You can similarly have a private goods approach to regulating or governing AI. So in China has these. I think in 2022 they passed the deep synthesis rules, which basically targeted the proliferation of AI generated media and content on the Chinese internet. And instead of banning that content outright, they basically said that that content has to be labeled, so anyone who's putting up synthetic content online, they have to say whether that content was generated by AI or whether that content was generated by human beings. And it's a private goods-based approach because the idea there is that through the signaling, the individual consumer can decide whether they want to consume that content or not. And so if they decide, in general, like if the individuals decide that they don't want to consume that content, then over time, the market will simply stop providing that content because it's not being consumed by the user. So there are basically limitations to both of these approaches. So on the public goods side, there's a possibility that a public goods approach might stifle innovation because the government might see the harms in certain things, but they might not see the benefits. But I think like the bigger challenge is that a public goods approach doesn't necessarily evolve with the risks. I'd given the example of the Asian Exclusion Act. So even though, in reality, the presence of Asians, clearly I'm an Asian in America, doesn't necessarily harm the American sovereignty in any sense. Those acts were around actually for decades and decades and decades, and I think over a century. And it took quite a long while for the government to change its mind about it. In the AI space, this is particularly important because AI is evolving pretty fast, and the harms of AI are evolving even faster. Any regulation that is made today may not actually address the harms that might emerge in the future. The other issue with the public goods approach is that the effectiveness of a public goods approach is really contingent on the knowledge of the regulator. Unfortunately, I would argue because, again, AI and especially AI harms are a relatively new space, regulators may not be as knowledgeable as we want them to be. And certainly, regulators are themselves constrained by, the availability of research about the harms available in the market at large. A private goods space approach has inherent limitations as well. So if you think about it, certain risks are externalized, right? So in that case, because the party that is making a decision about consuming a particular AI-based good or not, if they are not being harmed by the use of that AI-based solution, then they are not necessarily going to care about the harms, right? So if the risk is externalized, the primary entity, is not really going to care. The other issue with the private goods based approach is that oftentimes the risks of technology or really anything is not equally distributed in the population, right? So if it's unequally distributed, the populations that it harms less are going to adopt that technology or that solution, even if the harm is greater for other populations. Uh, so how does this apply in the context of AI? So consider facial recognition, right? So bias in these systems often actually impacts marginalized communities. It doesn't, it has, considerably less impact on communities that are more mainstream. Now, marginalized communities are also less likely to have political power, right? So, driving accountability for them, either using a public or private goods approach, is going to be, fairly hard. So one example I can provide that is not in my paper and that I just kind of thought of as I was preparing for the talk was in the United States now, like when you board an airplane, they can take a scan of your face and use that as a way to identify you. So you don't have to kind of do the manual verification. So it's an automated AI based verification. And there's some civil society groups that have done some really hard work to make it to basically have a TSA post signs saying that, hey, um, if you want to opt out of this AI system, you can. So you don't actually have to use the AI system, and that's a great idea, right? The problem with that is that if you are from a community that is going to be harmed by those AI systems, or where the AI systems may not perform particularly well, you are also not necessarily in a position of power when you're at the airport to basically go up to the agent and say, hey, I don't want my face scanned. I would like to actually go through the manual verification process. Like as a brown person at an airport, I'm going to do whatever I can not to stand out to anyone as being, being different from the crowd. So, I'm not going to go to and tell that agent, hey, I want to do the manual verification process. So, that kind of like sort of private based approach, has limitations. Now, another example is consider synthetic data. So I mentioned that a lot of in China the synthetic data, the approach to dealing with synthetic data is to say, hey, we are just going to label whether this content has been generated by AI or it is human generated. So, and this is an approach that is being promoted not only in China, but it's being promoted in a lot of different policy uh, places around the globe, whether it's India, Europe, US. However, there is really limited evidence to kind of uh, address the effectiveness of labeling. So, just because and there is one paper that I recently had to review, and it's not yet published. I don't want to divulge too many details, but the papers that I've read don't really show any evidence that would say that once people know that this data has been synthetically generated, they're less like they're equally likely to be convinced by synthetically generated data, even if they know it's been synthetically generated. So it doesn't necessarily prevent misinformation or disinformation. They're equally likely to share it. They're equally likely to use it or view it in the first place. So it's unclear whether labeling as a policy intervention really works, or to at least to what degree it actually works. um, so apart from these examples that kind of illustrate the fundamental limitations of a public goods or private goods approach to AI, there's some limitations that are particularly unique to AI. So from a public goods perspective, at the end of the day, any public goods based approach is usually going to be driven by the government. But when it comes to AI, the government has misaligned incentives about controlling the harms of AI. So, too many governments across the globe see AI as a competitive advantage, and especially when it comes to military use cases, law enforcement use cases, really the kind of use cases that are likely to cause the most amount of harm. So the government is, any if you look at the U.S. government, right, like they are going to kind of think about whether over regulating AI is going to put them behind the AI arms race when it comes to China. Does it put them at a competitive disadvantage in a in a kind of war fighting scenario? So the governments may want to regulate the harms of AI, but they might also just feel that the competitive advantage they get from new AI is too important to forego even in the presence of harms. The other limitation unique to AI is the poor understanding of risk and harms that we have when it comes to AI. There's this number that I saw that for every 300 people working in AI, there is basically one person working in AI security or AI safety. So that's a huge disconnect. You have like 300 people building new AI solutions, and only one of them actually trying to understand what are the harms from the AI that is being developed by the other 300 people. And for the most part, a lot of the harms of AI are going to evolve and emerge as AI gets more and more embedded in solutions in different sectors. Uh, and for the most part, like, the few AI safety researchers that we do have, they are not equally distributed, right? Like they're mostly kind of concentrated in the Fortune 50, Fortune 500 companies. But there are a lot of bias outside of those companies, right? Like they are not going to necessarily be able to differentiate between a good AI product and a bad one, right? So, but at the same time, they certainly do understand the benefits of it. So, with that poor understanding of risk, you might actually, a private goods based approach might also not work. I did put in that vendors might be judgment proof, which basically means that even if you can identify that a particular AI vendor is being problematic, and even if you are able to sue them for some AI related harms, unfortunately, or as the market currently exists, a lot of the people who are building AI based solutions are very, very small companies. And so, even if you find them liable for certain AI harms, they might simply declare bankruptcy, right? So you might not be able to hold them accountable. And that's basically what judgment proof means, that the party that is found at fault would not, they can basically just get out of it by, because they don't have the resources to pay for the claim. Uh, so this is where I'm proposing a slightly different way of thinking about AI governance, or regulating AI, which I call AI Swaraj. So Swaraj is a term from India. It basically just means self-governance, right? Now, when I sometimes mention the word self-governance, like people sort of assume that I'm just saying that, hey, it's just a free for all. AI vendors and AI companies can decide what they want to do in this space, and they can just come up, they can decide what harm needs to be addressed and what harm can just kind of, they can decide how much risk they want to take. And that's really not what I mean by Swaraj. Swaraj is a framework of self-governance that basically uses the inherent incentives of the resource contributors and I apologize, this resource users to collaborate. The resource users uh, word is missing from the sentence. And the way we do this kind of self-governance based on the inherent incentives of the resource users and the resource contributors, um, to that end, I think of AI as a common pool resource, and then I apply Eleanor Ostrom's common pool resource framework. And I'm going to go into the details of that in just the upcoming slides. But the idea is to have so AI Swaraj is basically a self-governance framework that doesn't rely on coercion as a way to kind of drive better AI outcomes. It uses the inherent incentives of the resource stakeholders. So very quickly, why should we, think about having a slightly different approach to AI governance, right? Why should we even think about this approach? So as I mentioned, right, it uses the inherent incentives of the resources stakeholders to collaborate, which means they have, less incentive to, do something that doesn't align with the rules. The second thing is, again, like, because it's based on inherent incentives, it's not really based on non-coercion. Non-coercion based governance is an idea from Gandhian ethics. So it kind of reflects, some of the values and approaches of the global South. Especially because the global South, by and large, is, politically not as powerful, and so, they have less of an ability to drive certain policy outcomes using coercion. Um, because it's based on Ostrom's kind of common pool resource framework, it kind of creates a sustainable governance framework that allows the governance criteria to evolve with the emerging risk of the resource being governed, which in this case is AI. Similar to some of the things I said earlier, it allows less resource stakeholders to have an equitable representation in policy intervention. And then, because at the end of the day, it is self-governance, so, any of the compliance related things or any of the other kinds of governance related action items that the governed are going to have to comply with, those are, because they are the people who are being governed by this framework are the ones coming up with the governance criteria. They are less likely to create unhelpful cosmetic regulation. So there is a lot of regulation that we see doesn't actually drive down risk, but it does create a lot of compliance work, which is just busy work, but doesn't really do anything to improve outcomes. So just very quickly, what are common pool resources? I understand there's a lot of economists on the call, so you probably already know this, but this is something that I really run into when I submit this paper to computer science and AI related conferences, because they are like, okay, what is common pool resources? So as I mentioned, right, like, you have private goods which are rivalrous and excludable, and you have public goods that are non-rivalrous and non-excludable. And those that dichotomy of goods, for most of the history of economics, most people assume that goods are either private or public, and that was it. um, but then, relatively recently, in the last, few hundred years, people decided that actually there's some goods that are non-excludable and rivalrous, and those are common pool resources. So think of a fishery, for example. So, it is rivalrous because if I go fishing and I catch a fish, that is one less fish for you to fish. But it's non-excludable because, we can both fish in the same fishery at the same time. On the other hand, you have club goods, so things like toll roads, which are excludable but not rivalrous, right? So if you're not paying the toll for your toll road, you cannot get on it. However, if I'm using the toll road, you can use it at the same time, so it's non-rivalrous. So the focus of this talk is not really club goods. The remaining of for the remaining part of the talk, I'm really going to focus on the common pool resources bit. So the first thing is the how do we and just very quickly, there for again for common pool resources are a relatively new introduction to the history of economics. And for the most part, for most of that history, there was this assumption that these commons cannot be governed by the people who live there. You really need, some kind of a government entity to take that over, or you need, some kind of a private entity to take that over, because people simply cannot, come together to make decisions about that resource. And that's kind of how you get national parks, for example, right? So the government takes them over and maintains them, manages them, and all that stuff. But then, in in 2010, Eleanor Ostrom, who had been looking at common pool resources, and was making an argument that actually you can absolutely avoid the tragedy of the commons by using a more formal common pools resource governance framework She won the Nobel Prize in economics for her work on defining the criteria that would allow the stakeholders of the common pool resource to just self-govern without having either public or private intervention. And so she basically identifies five different criteria for governing the commons in a way that would be sustainable and that would be led by the resource stakeholders rather than a public or private entity. So the first of those criteria is low cost of monitoring. So, as it kind of makes sense, all of the stakeholders, if they have come up with a bunch of rules to govern that commons, they should be able to monitor whether everyone is following those rules or not, right? So it should be relatively cheap to monitor whether people are following those rules. The second thing that the second criteria is low rates of change. So the resource itself should not change at a drastic rate, right? So it should only, so, if you are, for example, fishing, you cannot fish at a rate that would, not make the fishery unsustainable. At the same time, you cannot have too much change in the population of the stakeholders either, right? So, because if you suddenly have a lot of new villagers in a fishing village, they might decide, they have a different goal that they want to go after. The third one is social capital, right? So if you come up with a bunch of rules that everyone in the fishing village has to follow, and then you're able to monitor whether they are following those rules or not, then you need some ways of communication to basically be able to say, hey, that person has been following the rules, or that person has not been following the rules. And then based on whether they're following the rules or not, if they are not following the rules, for example, there has to be some low cost way to be able to penalize the people who are not following the rules and reward the people who are following the rules. And then finally, the people who are managing that resource at large should support the monitoring of that resource and the accompanying enforcement of any of the rules and norms that community comes up with. So that's kind of like those are the sort of five criteria that she came up with. Now, her work was primarily around physical resources, right? So she went around and did a lot of research along with her research staff and her colleague, who is also her spouse. They looked at fisheries, they looked at forests, they looked at like all different kinds of natural resources. And then they basically found that these five criteria had to exist wherever you had sustainable common pool resource governance. So how do we apply this to the AI use case? So first of all, we have to define the resource. So, you can break AI down into three constituent parts. So AI is essentially a combination of data, algorithms, and compute. Now, there has been some criticism of why you shouldn't just break AI into its constituent parts when you're thinking about AI governance. And I, a review of those criticisms, or why this kind of makes sense in spite of those criticisms, is kind of for is not something that I'm going to cover in this talk. But I think this is a good way of thinking about AI as its individual components. So you can have data, you can have algorithms, you can have compute. So let's look at just for example, let's look at algorithms, right? So you can think of algorithms as the resource that you want to govern, right? So you can think of algorithms as fisheries. So that's one resource you want to govern. Or you can also then look at algorithms, as separate data lakes, right? So Hugging Face is a data lake. I'm sorry, a model lake. PyPy. There are other places where you can get these algorithms as pre-trained models. So this notion of a model lake, that's been proposed by other researchers, and if I'm remembering this correctly, I think this was research from Timnit Gebru that proposed this notion of a model lake. And hopefully I'm saying her name correctly as well. But basically, model lakes are these places where people go to download and use to download AI, pre-trained AI models that they then used in downstream products. So, for the most part, most developers are not going to build their own models from scratch. They're going to download their models from places like Kaggle, places like Hugging Face, and um, other sort of model repositories. And this is not unique to AI. Most uh, proprietary software systems use, a plurality of that code is actually third-party code. So in the case of model lakes, so if you think about like something like Hugging Face, the people who are posting their models on Hugging Face, so think of them as resource generators, they obviously have an incentive to drive the use of their models, right? And one way they can do that is by signaling the quality of their models. At the same time, the resource users, which is the AI developers that are using those pre-trained models, they have an incentive to use high quality models so they can ensure that they're creating high quality products downstream. So to address this, Hugging Face proposed this notion of model cards. So there's some researchers at Hugging Face who collaborated with, I think, more independent researchers to come up with this notion of model cards. And model cards basically describe, what is the model, what is it trained on, what is the kind of use cases that are intended for that particular model, what are some of the performance related criteria around that model. So for example, if you have a model that is for facial recognition, how does it perform on faces with darker skin tones? So that's the kind of information that a model card is supposed to have. So to me, like a model card is basically kind of a way of creating social capital around the pre-trained models that you're contributing to that resource, right? But there's research that has actually shown that if you look at the information on those model cards, and by the way, the model cards do drive the use of models on Hugging Face. So researchers found that models that have a model card tend to be downloaded and used a lot more than models that do not have a model card. However, they've also found that if you actually look at the content of those cards, by and large, the information usually tends to be incorrect, or, and I apologize, I forgot to add this, it's either incorrect or incomplete. So even though they drive behavior, the actual information on those cards is not particularly reliable. So basically, when Hugging Face came up with the concept of model cards, they only address one criteria in Ostrom's five different criteria. They only satisfied the social capital criteria. They didn't have a monitoring regime, right, which would basically check and see whether the information on those cards is correct or complete, uh, which they could have done by creating a user support regime, by creating card bounties, for example, right? So you can basically say, if you're a user on that platform and you see incorrect information on a card, or if you see incomplete information on a card, you can report it to Hugging Face, right? So you can create bounties for the information on the card. And you can also, create user support for creating additional card standards. So maybe the model cards that are currently available don't have all of the information that a user might actually need to make a decision, whether they should use that particular model or not, right? So yes, your model cards have some information, but is that information actually relevant? Well, that's kind of unclear, and you can do that again through user support. So, if you did have that kind of a bounty kind of system, then you can also create an exclusion system so that's the fourth criteria in Ostrom's framework, whereby you can basically say if the information on a card is not complete or it's incorrect, you could basically remove that card. Or, if that information continues to be incorrect for a longer time, you could remove the model itself. Or if you see that a user purposefully does not provide correct and complete information across multiple models, you might just remove that contributor from Hugging Face overall. The final thing, of course, is you want to make sure that there's limited rates of change, right? So as new models are added to Hugging Face, you could also require people who are posting these models to basically create a lineage and say, hey, this model is actually based on this previous model that was already published. And then you can say, on average, you're going to remove or add, say, 5% of the models. So So you can kind of come up with some thresholds for exclusion, like how many models are you going to remove, how many users are you going to remove in a year or in a quarter. So essentially, if you think of like these model repositories like Hugging Face as a model lake, and again, lakes and these kind of natural resources are the kinds of things that Ostrom's framework is designed to provide common pool-based governance for. You can then apply that same framework to a model lake, so things like Hugging Face, and you can identify, what are additional governance steps that you need to take in order to have a more sort of comprehensive self-governance. So as I pointed out, really, Hugging Face did sort of one piece of that five-step framework. They came up with a way to declare social capital through model cards, but because they didn't have the other four pieces, they have some challenges with the model cards. Um, I do see I'm running a little bit over, so I'm going to quickly go through data lakes. So just like model lakes, again, you have data lakes. In the case of data lakes, resource users have an incentive to ensure data quality, right? Because you want to make sure that you're using high quality data, it's comprehensive, it's correct, and more importantly, it's not violating copyright, right? So if you're training your models, you want to make sure that you're not violating copyright. At the same time, the people who are contributing to those data lakes so that AI developers can train their models, they have an incentive because they want to be compensated, and the better quality data they provide, the higher the compensation they would get. So again, to address this, there's some researchers who have come up with this notion of data cards, and actually model cards. I believe data cards predate model cards, and model cards are based on data cards. So again, data cards are supposed to provide information about, what is the kind of data that is available in that database, and other aspects of that database. So again, data cards need to be combined with other elements in order to have a more comprehensive and more sort of sustainable governance regime. So, for data cards, you can actually easily create data benchmarks. So, you in this case, you can actually have some automation um, through benchmarks. And again, you can have the exclusion criteria. You can remove the card, you can remove the data set, or you can remove the contributor entirely. In this case, because with data with databases or the data sets, I'm sorry, because you can automate some benchmarks, you need less of a bug bounty approach. And instead, you can actually create a more sort of, create a different kind of compensation approach, or different kind of user support approach, where you can basically compensate users for contributing to a data set. So not every user has to come in and create a new data set. They can contribute to existing data sets and be contributed to and be compensated for it. And the other thing you can do is that, based on the quality of their data, so and the quality of their data cards, you can help them be better compensated for their data set through auctions. Of course, you can also have fixed price. Again, just like with model lakes, you can sort of limit the rates of change of these things by creating lineage with previous data sets, by limiting the number of data sets you add or remove at a single time, or how many data sets you allow people to update at a single time. The final one is compute. So we broke AI down into algorithms, data, and compute. So the final piece is compute. So in the compute piece, resource users have an incentive to get compute at the lowest price point possible. On the other hand, resource generators have an incentive to extract the greatest revenue. So if you look at how incentives were framed in the previous case, the incentives actually aligned. Resource users want to make sure data is high quality. Resource contributors also want to make sure that data is high quality because they want to be compensated. The better the quality the data, the more compensation they can get. Here, the incentives are not aligned. Resource users want the compute at the lowest price points, and you can make the argument that resource generators want to get the greatest revenue. That's not necessarily things they can, that's going to the lowest price point is not necessarily the way that they can extract the greatest revenue. So this is where you start to run into trouble, right? So, and the reason I provide this example is common pool resource-based governance is, I think, is an idea obviously that I believe is important, which is why I'm doing this talk. But it has also limitations, right? So if the incentives of the users and the of the resource users and the resource generators are not aligned, a common pool-based approach might not always apply. So in this case, so the social capital here, the one of the things that people have been proposing is that we should have vendor registries, so you can see what kind of vendors exist in a particular space. So let's say in this case, when we're talking about compute, we're talking about cloud compute that is needed for AI. So let's say you create a vendor registry that says, okay, all of these vendors provide cloud compute for AI. So the rate of change then is really the cost of the compute. So the monitoring is relatively easy because you can look at the marketing materials of the vendors who are providing the resource, and that will give you the cost of the compute. Well, the vendors can basically deny access to users who refuse to pay for that compute, and users can choose not to go with vendors who are overcharging for that compute, right? But still, generally speaking, because there's, if you look at the vendors that are available in this space, you only have a handful of vendors. So, for example, there's very, very few companies that actually make AI chips, right? So the users are very large, but the vendors are very, it's a smaller set of people. So they don't, and their incentives don't align. So they don't have necessarily the negotiating power that you saw in the previous use cases. So in this case, you may not be able to use common pool-based governance. And in this case, you might actually need a public or a private-based approach to governance. So in this case, for example, if you in the United States, the U.S. government has created the National Artificial Intelligence Research Resource Pilot. Sorry, that's a long name. And it basically provides lowest cost compute to people who don't have access to compute at a reasonable price point otherwise. So you do need those incentives for the resource users and the resource generators to align in order for there to be a common pool-based governance framework. So I know I've probably gone over time a little bit, but just very so again, why do we need AI Swaraj? Because we need a way to have sustainable AI governance where less resource stakeholders can have equitable representation and policy, and you can have a governance regime that can actually evolve with the risks of AI. So I'll stop there and pause for questions.